This video is on objective identify and understand the null and alternative hypotheses for an experiment with two population means. Alright, and so hopefully you saw the first video on this. I'll just get right into the question. It's a very similar question actually to the first video. Again, you might not see exactly the same problems I am, but the way you would go about them would be similar. So again, if you're unfamiliar with the topic, want to see more about what they're telling you, click on more instruction down here and look at their videos, their notes, their examples. Hopefully those help you out. So again, we're asked to identify the null and alternative hypotheses in the following scenario. So it's another one of them computer ones, just like the first video I did on this objective. To determine if computer 1 starts up slower than computer 2. The mean startup time of the two competing computers is compared, and the longer the startup time, the slower it is. Right? 22 startup times are randomly sampled from each population, right? The two populations, computer 1, all the computer 1s and computer 2s. Both populations have normal distributions with known standard deviations. Again, that's not going to be super important to us right now because we're only doing the first step of hypothesis testing. We'll get into more steps as the assignment goes on. Alright, so again, very similar to the last video where you have this mu1 is the startup times for computer 1 versus mu2 was the average or mean startup time for computer 2 models. And as with everything, every hypothesis test, there's some sort of claim or belief or something being determined in the test, in the scenario. Here it's, they're trying to determine if computer 1 starts up slower than computer 2. So the average startup time for computer 1 is greater than the average startup time for computer 2. Right? So this means that the computer 1's models are slower on average than computer 2's. And then once a claim is established, right, you can set up your hypotheses. There's the null hypothesis and the alternative hypothesis. This does not include equality, right? So that will be represented by the alternative hypothesis, that the computer 1 average startup times are greater than the computer 2 average startup times. And then the null and alternative hypotheses, right, they should be opposing statements. The opposite of is greater than is less than or equal to. So the null hypothesis is that the average startup times for computer 1 is less than or equal to average startup times for computer 2. Now, totally valid here, and this is what we're going to answer. But later on, when we see more steps to the hypothesis test, what we're going to do with this is we're going to be assuming the equality. Right, you're going to assume that the average startup times for computer 1 are the same as the average startup times for computer 2, and then later on decide whether or not you like that, based on the sample evidence. Are you going to reject this or fail to reject this? Also, how the alternative hypothesis looks tells you what kind of a test you're running, which will determine how many critical values you have if you're doing the critical value method, or it basically determines how you'd calculate the p-value if you're doing that p-value method. So here I have mu1 is greater than mu2, or if I subtract here, this is equivalent to saying that mu1 minus mu2 is greater than 0, and what I have here are parameters greater than a value. And if that's the case, then you're running a right-tailed test. Right, and I think I had a left-tailed test in the first video on this objective. And just remember that if it's not equal, if my alternative hypothesis was that mu1 was not equal to mu2, then it would be a two-tailed test. All right. So all the same kind of stuff that you saw when we were working with one population, but now it's two populations, but the same setup, pretty much the same setup, and things have pretty much the same meaning in this first step when setting up hypotheses. Okay, so the only one of these that actually match what I wrote is this one here, where the null hypothesis was that mu1 is less than or equal to mu2. The alternative was that mu1 is greater than mu2, or the computer 1s are slower than computer 2s on average, and great. Alright, and that's really it. That's all you're asked to do for these questions is set up the null and alternative hypotheses. So hopefully watching these videos helps you when you go through this stuff on your own, and thank you very much for watching.